Oh, hello guys. Today I'm gonna continue with the machine learning, the regression here. In the last video, I've taught you the linear regression, and in this video, I'm gonna teach you the polynomial regression here. Polynomial regression. So, first of all, here you talk plot x and y. So, it's really messy. Let me change the numbers. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. And here. 2, 4, 6, 8, 10, 12, 14, 16, 18. 20. It's linear, sorry. It's linear. Okay. Let me change the numbers. Hold on. If there is 14, 16, 18, 20, and 21. Let's see. Okay, just like this. Or I could put more. 11, 13, 15, 17, 19. 19. Okay. What? Okay. Doesn't go back. I didn't calculate the points here. Just randomly pick the numbers. Okay, so if I use the scatter, it should be like this. Scatter here. Okay, if I want to use if I want to express the polynomial regression, how do I do this? Just create a variable as numerical Python dot poly 1D, one-dimensional. Numerical Python dot polyfit. Y. Okay, let me tell you. Polyfit is polynomial fitting. Yeah. Okay, and the next one, line. Numerical Python line space 122 and 100. And here PLT dot plots line model line. Show it. Okay, I'm gonna explain it right now here. Okay. In here, you should learn the polynomial fitting first. It's on the discrete algebra, or you just type the polynomial fitting on the YouTube. There are lots of people who will tell you what does the polynomial fitting means here. And n is 3, so I could just say find the difference between these numbers 3 times. And it's hard to show you. Yes. If here's 3, So the difference between the three times difference is like this. If it's 4, you change the curve here. So it's the concept about the polynomial frequency. And the next one, time space. We start at 1. Here's 1. I mean this line is 1. Ends with 22. So here is 22. And 100 means you use a 50. 50 here. Hold on. 150. I think it's the how to say that there's no any significant change here. It should be the this distribution here. So okay, at the next one, R square here, R squared is really useful because we could measure the x value and the y value, the relationship between the x and the y values here. If there's no any relationship between the x and y here, it means that we can't use the polynomial regression to predict anything. I mean, just for example here. You just use the x and y here. Or it's a little, you need to import one thing, I forgot. You need to import from sklearn.matrix. Import how to score here, because we need to use this method. Okay, so in here, we will print autos underscore score 1 versus y model x. Yeah, let's see. Okay, let me explain to you. If it prints out, if here is 0, if it is 0, it means no relationship. Because the range here, the range is from 0 to 1. The 1 is the good relationship, and 0 is bad. There's no relationship. If the numbers is approximate to the 1, which means we could predict any numbers here, like the future value here. We can predict them. So just for example, if I just use the speed of this model 70, just like 12. If the x is 12, what does the y here is 13? Here is 13.69. Is because we know that it's really near to the 1, so which means we can predict the graph here clearly, and it's really accurate. Okay. So the next 1. The next one is about, or I show you the bad example about the bad relationship here. Here, okay, you can see. You can see the graph here. You can see it's really messy. The points and the line, the relationship is really bad. The relationship is really bad. So I believe that if I use the R2 score, the R square here, the concept R square. So here, if I print, if I could just copy, you should see is negative. But hold on, why is negative? I see the error. Where's the error here? I should match the name of the variable. Okay, you can see it's really near to the 0 because the range of the R square is from 0 to 1. If it is really near to 0, it means they have the bad relationship here. I could show you again. Hold on. So you can see that it's really messy and not cooperate. It's disorganized here. So you can see why you should get the 0.0099 here. It's, they have almost no any relationship. So if you try to plot the x value, and if you want to try to plot the x value and look at the future value, the predicted value is not really accurate here. So it shows the relationship between the graphs, between the line and the points here. So that's help you to analyze. Is the graph useful for people to analyze the value, the future value here by using this method? Okay, so that's the end for the machine learning tutorial session. Okay, so let's see you.